Dear students, today we are going to discuss chapter 2 Polynomials. You have studied about polynomials in your lower classes also. Polynomial is any algebraic expression which contain many terms. Now you can see here an algebraic expression 3x square plus 1x plus 5. So this is an algebraic expression containing 3 terms. So it has some numbers and it has some variables with different powers. So there are 3 types mostly we discuss. Any algebraic expression with one term is called monomial. Since you can see here only one term is there, so it is called monomial. If it contains 2 terms, it is called binomial, and if it contains 3 terms, it's called trinomial. The different terms are separated by plus or minus signs. Now we can categorize polynomials in some other way also. There are different powers of variables in the polynomial. So if the power of polynomial is 1, we call it linear. If power is 2, we call it quadratic. If power is 3, we call it cubic polynomial. So in this chapter we are going to discuss mostly about quadratic polynomials. Now we are going to discuss 2 important topics in this chapter. First, geometric meaning of zeros of a polynomial, and secondly, relationship between zeros and coefficients of a polynomial. Now first of all, what do we mean by zeros of a polynomial? Zeros of a polynomial means those values of variable that make the polynomial 0. Suppose we have any polynomial, say we take any polynomial 3x square plus 4x minus 5. Now we need to think those values of this variable x which will make this polynomial 0. Now in this, if we put x equals to 1, then we see that by replacing x with 1 and after solving we get the solution equals to 0. So x equals to 1 makes this quadratic polynomial equals to 0. So x equals to 1 is a 0 of this polynomial. And total number of zeros in any polynomial equation we can find by counting the number of times its graph or its curve intersects the x-axis. We can represent any polynomial on the graph also. So the number of times the curve intersects x-axis is called the total number of zeros in any polynomial. Now let's see some questions where we can find the number of zeros by looking at the curves. So exercise 2.1, let's see first question. In this we are given some graphs. We have to find the number of zeros in each case. So let us first of all look at first graph. If we see here, this graph, this curve is not meeting x-axis. We have to find the place where it is intersecting the x-axis. This graph is parallel to x-axis. This curve is not meeting it. So here for this case the number of zeros is equals to 0 because it's not meeting x-axis. Now let's have a look at second graph. Here we can see that clearly that this graph is meeting x-axis at this point. Only at this point the curve is meeting x-axis. So it has 1 0. So the number of zeros for this polynomial is 1. Similarly, if we look at third graph, here we can see that the graph is meeting, the curve is meeting x-axis at 3 points, 1, 2, 3. So for this the number of zeros will be 3. Now let's look at other graphs. For this we see that it's meeting x-axis at 2 points, so the number of zeros are 2. This is meeting it at 4 points, so the number of zeros are 4. And finally the last one, it is meeting x-axis at, you can count the number of points, 1 2 3 points, so the number of zeros are 3 for this. So this is how, by looking at the graph, we can find how many zeros this polynomial has. Now we are dealing with quadratic polynomials. General form of quadratic polynomial is ax square plus bx plus c. So here a is coefficient of x square, b is coefficient of x, and c is a constant term. Now we will discuss relationship between zeros and coefficients. One thing we should understand, if we have a quadratic polynomial, its degree is 2, highest power is 2, so it will have 2 zeros. So the number of zeros a polynomial will have will be equal to its degree. Now we will find the relationship between zeros and its coefficients, zeros of a polynomial and its coefficients. Now we need to remember this relationship, sum of zeros. Now we know this quadratic polynomial will have 2 zeros. That 2 zeros we can define, we can name them alpha and beta. So we can give name to these 2 zeros as alpha and beta, and sum of zeros will be equals to minus b upon a. If we add the zeros, we'll get minus b upon a, where b is coefficient of x and a is coefficient of x square. Similarly, product of zeros, if we multiply the zeros, their product is equals to c upon a, where c is the constant term and a is the coefficient of x square. So we need to remember these two relationships between coefficients and zeros of polynomial. Now we will verify these relationships in solving further questions. So let's see some questions. Before that, we can take one example also. Here we have a quadratic polynomial x square plus 5x plus 6, and we have already found its two zeros are minus 2 and minus 3. So we can give them name alpha beta, and we can see the coefficients of this polynomial from this. Nothing is written with x square, so means a is 1, coefficient a is 1, b means coefficient of x, that is 5, and c means constant term, that is 6. So we know coefficients, we know zeros. Now we'll try to verify the relationship. First relationship which we studied is sum of zeros, means alpha plus beta equals to minus b upon a. And the second relationship which we studied is product of zeros equals to c upon a. So we must remember these two results and we must use them. Now we are going to verify them. Now if we add the two zeros, minus 2 plus minus 3, we know we will get minus 5, and if we put values in this, minus b upon a, now b is 5, a is 1, so it will again give us minus 5 upon 1, which can be written as minus 5. So this relation is verified. Similarly, we will verify product of zeros. Now if we multiply these two zeros, minus 2 into minus 3, we will multiply them, we will get 6. And if we put values in c upon a, c is 6, a is 1. Again we get 6 upon 1, that will be 6. So here also we have verified the relationship. So this is how we can verify the relation between coefficients and zeros of a polynomial. Now let's try some book questions from exercise 2.2. Our first question is, find the zeros of following quadratic polynomial and verify relationship between the zeros and the coefficient. So the quadratic polynomial we can write, it is x square minus 2x minus 8. So first of all we will find its zeros. Now how can we find zeros of a quadratic polynomial? For finding its zeros, we will use factorization method, in which we will split the middle term and find its two factors. Now first of all we will multiply first and last term. The product of first and last term is minus 8x square and the middle term is minus 2x. Now let's think of two numbers whose product will be minus 8x square and whose sum will be minus 2x. Now we can think and we can write 4x and 2x. If we take these two numbers and if we take minus 4x and plus 2x, on multiplication they will give minus 8x square, and if we add them then we will get minus 2x. So this is how we can split the middle term. It can be written as minus 4x plus 2x, because we know 4 2s are 8, so we will get this, and 4 minus 2 is 2. But we need minus sign here, so we will keep a minus sign with the bigger number. So now we will replace minus 2x with its terms, two terms into which we have split it. So we will write x square minus 4x plus 2x minus 8. Now taking x common from these two terms, we will get x in bracket, we will be left with x minus 4. Similarly, taking 2 common from these two terms, we will get x minus 4 in the bracket. Now these two brackets are again same, so we can take this bracket common one time, we can write, and in the other bracket we will be left with the remaining terms, that is x plus 2. So these are the two factors of this quadratic polynomial. Now to find zeros from these two factors, we will equate them equals to 0. So first we will put x minus 4 equals to 0 and then x plus 2 equals to 0. They will give us x equals to 4 and x equals to minus 2. So these are two zeros of this polynomial. So we can give them name alpha and beta. This can be our alpha, first 0, and this can be beta. Zeros are also known as roots of the equation, roots of the polynomial. So here we have found alpha is 4 and beta is minus 2. Now we have found the zeros. Now we will verify the relation between its zeros and coefficients. Now let's verify the relation between its zeros and coefficients. From this polynomial, first of all let's write coefficients a, b, c. A is 1 because nothing is written with x square, means coefficient is 1. B is minus 2, the coefficient of x, and c is minus 8. Now we have already found the zeros of this polynomial alpha and beta. In the previous solution we have found alpha is 4, beta is minus 2. Now first of all we will write the relation between the sum of zeros and its coefficients, that is alpha plus beta equals to minus b upon a, and product of zeros alpha into beta equals to c upon a. Now let's insert values in this. Our alpha is 4, beta is minus 2, so we will write 4 plus minus 2. This will give us 2. Now putting values of coefficients in the right side, minus b upon a, minus b's value is minus 2, so we will write minus 2 in the bracket. This minus sign is of formula and this minus 2 is because b is negative, upon a is 1. So now minus of minus 2 will become plus 2. So 2 upon 1, it's 2. So we have verified here the left side equals to right side. Now let's verify this relation also. Here product of zeros means 4 into minus 2 equals to c upon a. C is minus 8, a is 1. So minus 8 upon 1. Here also on solving both the sides become equal. So here also we have verified the relationship. So this is how we can first find out the zeros of the polynomial by using factorization method, and then verify the relation between zeros and its coefficients. So I hope students you are understanding how we can find zeros of quadratic polynomial and then verify relation between them. This is very important question. It's generally asked in the exam. Now we will practice, we'll see the solutions of some more quadratic polynomials and verify their relations. Now in this example, we have quadratic polynomial 6x square minus 3 minus 7x. Now one thing you should observe here is that they have written constant term in the middle and term containing x at the end. So you need to shift the terms first. You have to write the quadratic polynomial in standard form in decreasing order of the power of x. So you bring this term in the middle and this term you take to the right. Now by multiplying first and last term we get minus 18x square and the middle term is minus 7x. Now we'll think of two numbers whose product is 18 minus 18 and whose sum is minus 7. Now we know if we multiply 9 and 2 we will get 18, and if we subtract 9 and 2 we will get 7. We need minus 7, so we will keep negative sign with the bigger number, that is 9. So minus 9x plus 2x, they will give minus 7x. So we have written the middle term as minus 9x plus 2x. Then taking 3x common from the first two terms, we will be left with 2x minus 3 in the bracket. Taking 1 common, we will get this. Now 2x minus 3 will take common, and in the other bracket we will get 3x plus 1. Now putting both equals to 0, we will get two values of x, that is 3 by 2 and minus 1 by 3. So these are alpha beta, two roots of the quadratic polynomial. Now we have found the two zeros of the polynomial. Now we will verify relation between zeros and coefficients. So here first of all we will write the two zeros are alpha beta, I have written here, and the coefficients are a is 6, b is minus 7, the coefficient of x, c is minus 3, the constant term. Then the formula for relationship alpha plus beta equals to minus b upon a. Putting values of alpha, beta and the coefficients, we can solve them and we will find that the two relations are equal. So you can see the solution here. Similarly, I have proved for product of zeros also. So student, this is how we can verify the relationship. If we have been able to find the correct zeros of the polynomial, then every time this relation will be verified. Alright. Now one more example we do. Here we have 4u square plus 8u. This polynomial has only two terms. Now we will take 4u common. In the bracket we will be left with u plus 2. So when there are only two terms in the quadratic polynomial, we need not to use the factorization method. We can simply take out the common terms and make its two factors like this. Now we have got two factors, one is 4u, other is u plus 2. Now we'll put them equals to 0 to find the two zeros of the polynomial. So we'll get here 4u is 0, so u will be 0 upon 4, that is 0. And from here u will be equals to minus 2. So these are the two zeros of the polynomial. We can give them name alpha, beta. Now we will verify relation between the coefficients. Now we know the quadratic polynomial is this. So here coefficient of u square, a is 4, b is 8, but we don't have constant term, so c is 0. Now let's verify them. We know sum of zeros is minus b upon a. So we will add alpha and beta. This is alpha, this is beta. If we add 0 and minus 2, we will get minus 2. And equals to minus b is 8 a is 4. So minus 8 upon 4 we will get on solving minus 2. So we have been able to verify it. Similarly, we can verify product of zeros. Alpha into beta equals to c upon a. So the zeros product is when we multiply 0 with minus 2, we will get 0 equals to c upon a. C is 0, so 0 upon a is 4, that is again 0. So this relation is also verified. Now one last sum we will practice today, that is t square minus 15. Now how can we make its factors? Now simply we can use identity, that is a square minus b square equals to a plus b, a minus b. Now here it is t square, and we know 15 is not a perfect square of any number, so we can write it as root 15 square. So when we put them, we can write them in two brackets, t plus root 15 and t minus root 15. When we don't have any perfect square, we can take its square root. Like we know root 15 into root 15 will be equals to 15. So we can write 15 as root 15 square. That's why here 15 I have written as root 15 whole square. So here we have used this identity, a square minus b square equals to a plus b, a minus b. Instead of a we have t, and instead of b we have root 15. Now we have got two factors here. Now we'll equate them equals to 0, and we will get two zeros of this polynomial. So when we put them equals to 0, here we are getting t equals to minus root 15, and here t equals to root 15. So these are the two zeros of the polynomial. We can give them name alpha, beta. And similarly you can verify the relationship between their zeros and the coefficient. So students, I hope you have understood how we can verify relation between the zeros and coefficients, and how we can identify the number of zeros of a polynomial by looking at its curve on the graph. So hope you understood. Practice more questions. If any doubts, feel free to ask. Thank you for watching. Please like and subscribe the channel for more such videos.